In this video, we're going to cover some basic high-level constructs, and we're going to see how we can write them in our assembly language. So for example, we're interested in if, then, else, for, next, do, while. So we want to be able to generate these high-level language loops in our assembly language. Now, I've picked out a few of them here which we are going to cover. So we will cover the do while, for next, if then else, if then, switch, and while. So if you've done computer programming, you'll know what all this is and it'll all be pretty straightforward. But it's well worth covering some of the basics here. Now, I've picked these out, pretty much because these are the typical sorts of basic language constructs you'll find in all computer languages. They might look slightly different from one language to the next, but they will perform pretty much the same logic. So let's start off with the if then. So all I'm going to do in this video is just have a little talk through how we can generate this using our assembly language. And you can see that I've actually commented out stuff here. So the stuff that's commented out isn't the actual assembly language. If it's not commented, then that's the actual assembly language that we're going to use. So the if statement would be somewhere along the lines of if x is equal to y, then you perform an action. So then the action will have several different lines, and then we'll have the end of the if statement. And then after the end of the if statement, the program will continue along down its merry path. Now, if we were to write this out in our machine, in general, if we want to work with any values, then they're going to have to be brought into the registers first. So we may have to say go to memory and pull out information from memory and bring it into a register. And we will start off with the information in the register. Now, that's not always the case because we do have some complex instructions which are able to manipulate memory locations. But we won't bother looking at that. We'll just assume that we're going to have to take some stuff into the registers. So we're going to have to take x and y into the register. So we've got the data x will be placed in R0 and data y will be placed in R1. Now we're going to go through the compare function because we need to do the x is equal to y. So that is a comparison. So we're going to clear the flags first before we do any arithmetic operation. So we're going to compare register R0 and R1. And the next line, we're going to jump if not equals to exit. So if x doesn't equal y, then we don't go into this construct here. We just jump to the very end and we move on to the rest of the program. So we just jump over that whole block and then continue with the rest of the program. So we jump if not equal to exit. So head up to exit. And at exit, it just continues with the rest of the code. Of course, if this isn't true, so if jump if not equal isn't true, then it will continue down and we will then be inside this loop and we will actually cover action 1. So we will complete action 1 in here. Now, whenever action 1 is completed, we will jump on to the exit again and we will get down to the next line of code. So that's relatively straightforward and self-explanatory. And you can see that the actual construct here within our assembly language is not much longer or bigger than the actual code written in our high-level language, and it's relatively straightforward to understand. So let's move on to the next one. So let's look at the if then else. So again, you can have a little read of what the logic is up here. But what we've got is, if x is equal to y, then we perform action 1. So we don't perform action 2, we only perform action 1, and then skip over action 2 and go on to the rest of the code. Now, if x doesn't equal y, then we don't perform action 1, we skip over that, and we go directly to action 2, and we only do action 2. So at no point do we do both action 1 and 2, it's only either one of them or the other. So you can see here again, we take the x into R0, the y into R1, we clear the flags, and then we do the comparison. Now, if it isn't equal, so jump if not equal, then we're going to jump to action 2. So we jump over to action 2, we perform action 2 here, and then we continue down through the rest of the code. Now, if this jump if not equal isn't true, so that is, it is actually equal, then we perform action 1. Now, when we've finished performing action 1, we then jump over action 2, so this is the JMP to exit, so we jump over action 2, and again we go to the exit and continue with the rest of the code. So again, relatively straightforward, and you can see that there's not very many lines of code in our assembly language that we need to write in order to perform this high level function. So let's move on to the next one. Now let's look at the for next loop. The basic construct is for k equals I to j, we perform action 1 and then we go back to the beginning of the loop. So let's say, for example, the value of I is equal to 1 and the value of j is equal to 5. Then we perform action 1 for the value I is equal to 1, 2, 3, 4 and 5. So crucially, at the end, whenever the comparison is true, we don't finish the loop. We go back and we work through the loop one more time to get the 5th value. Now we're going to have to put values into the registers. The value for I is going to get in our index register because this is the counting value 1, 2, 3, 4, 5. The value for j, which is the top end here of our loop, is going into register R0. Now we're going to be using an add function here, so we'll clear the flags first of all. And in order to ensure that we get through the loop for the very last time when the comparison is true, we'll actually add 1 on to the value of j. So now we're going to have 1 added on to register R0 and saved in register R0. So now j in effect is a value 6. So we have to do this to ensure that we get through the loop for the final time. So we perform action 1, we then clear the flags again, we add 1 on to the index register so it goes up to 2, we do the comparison with our I and our j. If it's not equal, we go up to action 1 and then we continue around this loop. But of course we're going to continue around the loop until actually we get to the value of 6. So at the value of 6, it will force it to go through this action one more time. So that will actually give us our 5th route through this code. And then it will jump to the exit and we'll continue with the rest of the code. Now let's look at the do while. So in this case here, we do action 1 while x is equal to the value of y. So it means that action 1 will go through at least once before we do the actual comparison. So we can put the value for x into register R0, y into register R1. Now this is the start of our loop here. So we go through the actual action first of all before we do any comparison. We then do the comparison with x and y, so that's register R0, R1. And then we jump if not equal to action 1. So if it's not equal, we jump up to action 1. and we continue doing that until eventually the value x is equal to y, in which case we go to the next line here, which is our exit, and we go through the rest of the program. So that's quite straightforward. Now let's look at the while loop. Now this is similar to the do while. The only difference is in the do while we perform the action at least once before we do the comparison. In the while loop we don't perform the action until we have gone through a comparison. So there's the possibility of going through the comparison and the action never actually occurring. So the basic construct would be, for example, while x is equal to y, perform action 1. So again, we put the value x into R0, y into R1. We start our loop here. We go through the comparison. We compare R0 to R1. Now, if it's not equals, then we jump to the exit. So we have the comparison x equals y performs action 1. So if it isn't equal, we don't perform action 1, in which case we just jump to the exit. Now, if the value x is equal to y, then we perform action 1 and we jump back to the repeat. So again, we do the comparison and we jump if not equal to exit. If it is equal, then again we perform action 1 again, and we continue through that loop until the jump if not equal comes true and we jump to the exit. Now finally, let's look at the switch statement. Now there's a bit more involved in this, but it's still relatively straightforward. We're going to have an expression, so this could be something simple like a value. So for example, the value 2. So we will be making a comparison between, say, this value here and a value 1, value 2, and we could have multiple different values that we're making the comparison with. So let's say, for example, this was a value of 2, and it came down here, and this case here was value 2. So we would be making the comparison between a number 2 here and a number 2 here. So whenever there's an equality here, it will jump into this block of code and run this block of code, and then it will break and go to the next section of your code. Now we may have an expression 1, in which case it would jump into this value here if this value was set at 1. Now if there was no expressions here, that is, there's no equality here with any of these cases, it'll just jump to a default case at the end, and again it will finish and move on with the rest of the code. So in order to generate this, we're going to have to put the values into the registers again. We can put the expression into register R0, so this could be a simple number. We compare the hash value 1, again it's a simple number, in with register R0. We jump if equal to that case 1. So if we jump down to case 1, we would run through the code, and when we've finished running through the code, we would then jump to the end. So switch to the end, we go to the end of the code block. Now we can go through and do the comparison again, so we can compare with value 2 in R0, and we can jump if equal to that value 2 block of code here, and then jump to the end. So we can keep adding in more and more comparisons and jumps. Now if none of these equalities are met, then it'll just jump to the default case. So here's the default case down at the bottom. So we go through this default case and then we go to the end of the code. So that's us covered a few basic constructs, but from those basic constructs we can generate really complicated code. So we've got the building blocks here that will allow us to generate some nice code. So thank you for listening. I'll get you on the next time. Goodbye.